The important thing that happened to us in 2003, we brought in science into our operations of our ranch with the idea of informing how we were approaching managing our grassland system. And it's 540 acres. It's in Marin County. And I'm not sure how much people had heard what I was saying when I started, but we had removed grazing from our ranch with the idea of creating wilderness, and it failed. Our natural system in Marin County was beyond the point where, left alone, it would achieve what we were hoping to see was to be a natural state, reminiscent of what the historical system had been. We removed grazing, and encroachment from weeds and brush quickly spread over the landscape, and we clearly didn't understand what was happening. So we brought in Dr. Jeffrey Creek, a PhD rangeland ecologist who's a systems thinker. And Jeff suggested that we reintroduce grazing as a strategic tool to achieve our management objective, which was to promote native ecosystem function. So we borrowed a herd of cattle and we started grazing our ranch, and we did it with a very strategic grazing management plan. And after just a few short years, what we saw was very impressive. We were seeing native plants appearing without planting any seeds. All this time, Dr. Creek was suggesting that what we were seeing was an expression of increased soil carbon. 2006, Governor Schwarzenegger had signed into law AB 32, and it was our thinking at that point in time that if in fact we were increasing durable soil carbon, perhaps with this new discussion around cap and trade, there might be a new financial mechanism to help ranchers and land managers stay on their landscape performing agriculture with a new revenue source. And so our effort to create carbon and increase soil carbon and create carbon credits required that we be able to measure that. And so we reached out to UC Berkeley, Dr. Wendy Silver, a biogeochemist, to establish whether there was a protocol for soil carbon sequestration measurement. That initial inquiry resulted in some research because we weren't sure, in fact, that the type of carbon we were increasing in the soil would count for carbon credits. It may have just been labile carbon that cycled rapidly through the system. So in order to determine whether the carbon we were increasing in our soil in a durable form would actually be measurable and significant, we conducted several experiments on our ranch starting in 2008. And what we were able to show through our research is that, in fact, yes, you can intentionally increase soil and that it's a durable form. And what was exciting was that once we started managing for carbon in our system, we increased the system's capacity for even more carbon. And once we managed for carbon one time, from then on, the system itself started taking in more and more and more carbon from the atmosphere. For 5 years now, we've measured a ton of carbon per hectare increase in our soil in a form that is significant. It's in the heavy fraction carbon, and this would qualify for carbon credits. And so our measurements for 5 years of this steady flow of carbon from a single event of management is exciting. And when the computer model run shows that that will continue for 30 or 100 years, this becomes very exciting. So what we had done by asking the question, can we increase carbon? We used a scientific experiment applying compost. It was not our intention to put compost on grazed rangelands globally. It was purely a scientific inquiry. Can we increase soil carbon? And the results were so exciting that we've actually now developed the protocol for compost application on grazed rangelands, which has been approved for carbon credits under the California Association of Air Districts. So in the end, we've actually achieved that objective of creating a carbon credit mechanism that would be able to be funded by people seeking to offset their mitigations. So for CEQA mitigation, for instance, this protocol has been approved by the American carbon industry. The next question is, how do we excite consumer behavior to support agricultural practices that in fact are climate beneficial? And so a lot of our work now is focusing on several other different projects. The Fiber Shed project, Rebecca Burgess and that group are a perfect example of climate beneficial durable goods that were derived from restorative agricultural practices. So in support of that kind of agricultural effort, we've further worked with Colorado State University to create a new online tool in collaboration with the USDA. It's called the COMET, COMET hyphen planner. And this is a way now for agriculturalists to collaborate with the USDA and gain access to Farm Bill funding to look at their entire operations of a ranch or a farm or any other system and look at the net greenhouse benefits of it. And the Comet Planner, the new online tool with the USDA, lists 35 practices that the USDA and the government now recognize as soil health, soil carbon beneficial and greenhouse gas beneficial. And this is a very simple method for agriculturalists to determine if their entire operation can end up being a net climate beneficial agricultural production system. So that's very exciting. The Fibershed project has now been able to demonstrate that we can produce fiber and textile products from agricultural systems where the purchase of every garment actually is a net climate benefit. It's a very exciting expression of this kind of thinking. Another question that came up from our research was, since compost as a research question was so successful, what's the reality of creating enough compost and getting it out on different land masses? So our research was focused on grazed rangeland systems, and we've scientifically developed an understanding of the mechanism of photosynthetic transfer of carbon between carbon pools. Very exciting. The next question is, does that mechanism also work in row crop systems, in urban soil systems, in forest systems? And how do we determine what the highest, first, and best use of these compost products are? So we're continuing that exploration now with a group at Lawrence Berkeley National Lab in UC Berkeley. So soon we'll have an understanding of the highest, first, and best use of compost. But then also, what are the other available compost feedstocks that currently are not being composted? And we've identified that dairy manure in California has a tremendous greenhouse gas emission potential. And if we get it into compost rather than into the wet dairy lagoons, we can eliminate an emission and create a very large amount of material that could be composted and put out on landscapes. That's exciting. Some of the other work we're doing, working with Dr. Gary Anderson at Lawrence Berkeley National Lab, is to look at the potential of human waste being composted. Now, human waste compost is scary to a lot of us because the potential for pathogens, pharmaceuticals, hormones, and all these other things. Our research now on a state licensed county permitted research project on our ranch has shown at the first phase that we could destroy pathogens with certainty through thermophilic bacteria composting as conducted under the Cal Recycle specifications. Very exciting results. So we were able to show using the Philo chip and Dr. Gary Anderson's team, we were able to show that we can compost human waste and destroy pathogens. That worked. That then justified the further research, which we're now conducting, looking at the destruction or deactivation of pharmaceuticals in human waste. We're currently composting ibuprofen and Cipro. So we're looking at a blood thinner and an antibiotic. So far, it looks very promising. The next phase after that success will be looking at hormones and endocrine disruptors and things of that nature. So if we're successful and can show that we can manage human waste as a new feedstock for agriculture, I think that's a very important thing. We can compost human waste and possibly in our collection of human waste, avoid using fresh water to transport it. So there's two different tracks that the project is taking, and we're actually calling it the Thermopile, THERMOPILE project. We have a website, thermopileproject.org, and you can see the preliminary results from the pathogen destruction. But the science around the composting is one track. The other track is to determine whether, in fact, there are collection devices, toilets, where we can eliminate the use of water. So we're organizing now and testing different toilet technologies to determine if we can avoid using fresh water for human waste. And the hope here is that we could revisit how we manage our waste streams, and identifying the potential for human waste is important because that's kind of the boundary. Then anything else less dangerous or threatening than human waste also has tremendous potential to be composted. So that's one track. The actual conventional composting is also a research project that we're working on in Cascio at the La Franchi Dairy right now. This is at the West Marin compost facility. And we're just now putting in a very elaborate measurement technology that relies on a laser that has 16 ports, and we're able to measure all of the greenhouse gases coming off of a conventionally managed dairy manure based compost. And based on that, and I say we, this is actually Dr. Wendy Silver and her team at UC Berkeley, we'll be able to get to the first principles of composting. And by understanding the carbon and nitrogen cycling and the different emission profiles from different management practices, we'll be able to optimize the production of compost in a way that produces the least amount of greenhouse gases and the maximum soil carbon sequestration benefits. Some of those benefits include, in addition to the actual carbon cycling, what we've been able to show through our research is that when you do manage for carbon in the soil system, you increase the soil water holding capacity, which is very important in California right now, looking at the drought condition that we're in, but also the plant production that we increased, and we've seen up 50% increase of biomass production on these composted plots. It turns out that production is more nutritious biomass. So managing for carbon in these soil systems has resulted in a cascade of measurable benefits. It's very exciting. And we look at what that means and how we can satisfy the human material cultural needs with these solutions that are based on restorative agriculture. This becomes a very exciting conversation. And I've kind of lost track of time here. You want to do a time check? I'm not sure if I'm running over or what's going on there.
You still have time. You still have another 8, 10 minutes.
Okay. So, at that point, I'm wondering, should I just take questions? That's kind of the background story. And,
okay. You're ready for that? That'd be great. Okay. I have a couple myself. So, John, when you talk about managing for carbon in rangelands, can you talk about, annual versus perennial, and also natives versus introduced species? And have you done work with that? And what are the results in those in regards to plant communities in the rangeland?
Okay, yeah, that's a great question. And actually, I was up at UC Davis at the Natural Resource Conservation Service office yesterday, having the same conversation there. And in that meeting yesterday, there were some peer-reviewed published papers that were presented, and there is definitely now research that shows that deeper rooted perennials have a higher carbon sequestration value, and so managing for perennials becomes a desirable thing. And I can speak personally about that because our effort on our ranch now remember we're looking at grazed rangeland systems. And let's back up a couple clicks here. When we first started our inquiry, looking at how I managed grass on our ranch, and Dr. Creek was suggesting that grass is exciting because if you think of every little grass plant as a straw that sips carbon out of the atmosphere, that's pretty cool. I had never thought about this stuff before this project, but soon learned that during the process of photosynthesis, plants actually take carbon out of the atmosphere. We all know this, and then combine that with soil moisture that comes in through the roots to create carbohydrates. I had never thought about it, but all of the carbon and carbohydrates comes out of the air. Had you asked me before this project, I probably would have thought that carbon came in from the soil carbon. It's the opposite, and that's what we've shown. So the deeper rooted perennial plants have more material and more transfer or transformation of atmospheric carbon dioxide into biospheric carbohydrates. And some of those plant-based carbohydrates now can enter the soil system and end up in a more durable fraction. And so the research shows now that deeper rooted perennials transform more carbon into carbohydrates and transfer that carbon into the soil in a durable form. So it's a good thing. Our management of grazing on our ranch was targeting promotion of the deeper rooted perennials. And I've shown personally that you can be very successful at that. It is hard work, and you have to be very strategic about when you introduce the disturbance that grazing can be. And by waiting for the annual plants, and in our case, it's the exotic oats that came with the Spanish in the 1500s into California, by managing my grazing disturbance so that the oats have just started to express flowers and are about to produce seeds, that's when I introduced the cows. And they remove that competition, which allows now the sunlight to get at the growth crowns of the perennial plants. And After just a couple of years, we started seeing the native deep-rooted perennials thriving. And at this point, I've got about a 20% coverage of deeper rooted native perennials from my grazing management alone. The challenge for me is that thinking that what I was doing was also increasing soil carbon, we conducted some very simple research where I put in 6 blocks of plots with controls, where I did my most intense grazing disturbance, intentionally trying to promote native, deeper rooted plants and sequester carbon. After 4 years, only 4 of the 6 plots showed any biomass response to that grazing disturbance and no change in soil carbon in a beneficial way. So I'm still struggling with trying to figure out how grazing alone can increase soil carbon in a degraded system, which mine is. I've got very low soil carbon levels to begin with. And it's quite possible that in a higher carbon level site where you have 5% or more, that grazing disturbance would have had a different outcome. But in my system, in a Mediterranean coastal prairie system in California, my grazing alone did not increase durable carbon yet. Now, it may take 2 decades or something like that. And Richard Teague at Texas A&M, that's what he's thinking, is that using grazing as a tool to increase soil carbon by steering the system towards perennials is a powerful tool. It's a long-term strategy. For me, the exciting thing is that where we put compost and ignited a state change through a compost application, from then on, that system has just rushed towards deeper rooted perennials. You can look at my test plots now, where a half-inch compost application in 2008, 7 years later, is dominated by purple needlegrass, and we did not plant a seed. And there are no more weeds in that system. And right next to it on the control plot, same grazing pressure, no compost. It's got an annually dominated species composition and a lot of weeds and is losing carbon to the atmosphere. So I know I'm kind of rambling around here, but that was a very interesting question.
What is the conclusion? What exact do we know? Do you know what compost is doing to kickstart the carbon sequestration in your rangeland?
Yeah, it's quite simple. There are 4 pathways where that atmospheric carbon can become durable soil carbon. The first pathway, of course, is the development of plant tissues, which are carbohydrates. And as those roots, which are carbohydrates, are in the soil system, during different events in the plant's life, it sucks some of that root tissue. And at the same moment, plants are discharging a tremendous amount of sugar out of every pore on all the roots. This sugar, this carbohydrate that was atmospheric carbon, is food for the beneficial microbes and the different organisms in the soil that act as the immune system and digestive tract for a healthy plant in the healthy soil system. So now the plant is creating plant tissues, exuding sugar, and it also has a really nice association with mycorrhizal fungi that extend a plant's ability to retrieve nutrients from great distances. 80% of soil carbon is in the form of glomalin, which is the sticky, sugary stuff that the fungus makes tubes out of to bring nutrients back to the plant in exchange for more sugar. And then so there's the root tissue, the exudative sugar, the association with mycorrhizal fungi, and then the fourth pathway is the natural accumulation of litter, which is plant tissues, manures, dead bodies. And soil systems, healthy soil systems, have populations of different organisms who can bring that biologically stable carbon and nitrogen slowly down into the soil at a plant available rate. That's the pathway we primed by putting compost on it. Once, and in our research plots, we had soil and temperature probes. We saw immediately that the composted sites had a higher water holding capacity, which resulted in more plant growth, which removed more carbon from the air, which increased carbon, which held more water, which promoted more plant growth, and it goes on and on from there. So that initial bump of energy in the form of compost into the soil ignited a state change. And from that point forward, those plots on their own now are self-organizing and self-feeding in a way that removes more and more and more carbon from the atmosphere, and it ends up in a very good durable form in the soil.
So California is the #1 dairy state and the 4th largest cattle producer. So you would think that there would be an abundance of raw material for this, and you mentioned most of this is going into manure lagoons and is a toxic waste situation, as well as greenhouse gas emissions. How do we get from there to making that resource available in a positive way?
Yeah.
And will it fit into cap and trade? Is it eligible for that?
Yeah, that's a great question. I do want to clarify. I don't think that the dairy manure in lagoons is toxic necessarily. That's a pretty strong word to use there, but it is absolutely under anaerobic conditions creating methane and nitrous oxide.
Well, toxic in the sense of pathogen producing.
Yeah, I'm not sure about that. But anyway, what we have is one of the more recent peer-reviewed papers that Wendy Silver's lab has produced is an analysis of the dairy manure management in California. And in that research, they've shown that there's a tremendous opportunity here to look at this feedstock and potential feedstock as a source of compostable materials. And it looks like right now in California, there's enough mobilized waste that we could compost that is currently not being composted. But if we could compost it, we could address the pathogens and the toxic issues you're describing and create enough material to cover a significant amount of the land area. What's exciting to me is that by doing that, based on our research, you wouldn't have to go back and do that again. From then on, that treated area on its own would start acting as a carbon sink, which it is not currently. So that means we could then capture next year's waste streams, create compost out of them, therefore avoiding emissions that were associated with anaerobic conditions, and then start another area being treated, and then on and on and on. And soon we could increase, and this is really important to understand, California's, and I think globally, systems have lost a lot of carbon. Dr. Jeff Creek talks about globally, our soils have lost 60 to 80% of their carbon through our management. So I'm not talking about changing or introducing a new thing, but actually just replacing some of the carbon we've lost historically. And then the system itself knows how to handle that carbon and move forward on its own. So it's not a dangerous thing we're proposing here where we're trying a new thing in the system, but rather reintroducing carbon back into the system where historically it had been. And the cascade of benefits that happens when you focus on carbon is so exciting.
Darren Doherty, from the Australian permaculturist, he says that an increase, 1.6% increase in carbon on all arable lands globally could turn climate change around in a matter of decades. Have you done any work with Darren?
Yeah, sure. It was actually that comment from Darren in November of 2007 that put me on this track, and I'm really grateful to him for that. That statement was, he got that from Alan Yeomans in the book that Alan wrote, Priority One, I believe. And it turns out that Alan had gotten that from Dr. Ratan Lal, who's at that time in 2006 or 7 was the president of the Soil Scientists of America. We reached out to Dr. Lal based on that statement of Darren's, and the arable systems on Earth, it's 1.5 billion hectares, and that's great. And based on Dr. Ratan Lal's calculations, we looked at the rangeland system and determined what it would take to increase, or how much carbon we could remove from the atmosphere by increasing soil carbon in rangeland systems. And that became very exciting because there's 3.5 billion hectares of grazed rangelands. So it turns out it's a fraction of that number for the rangeland systems, but not all of them are accessible and not all of them should be managed this way. We actually need some of the rangeland systems to not have so much carbon in them. So it's an important conversation to have. Where are the appropriate places to manage for carbon?
Renata, I wanted to invite you and see if you had a question for John. Can you hear me, Renata?
Yeah, hello, Renata.
Renata, are you there?
I'm here.
Can you hear me? I don't know. Did we lose John?
Can you hear me?
I don't know what happened.
I'm here. It was kicked off, but I'm back.
Okay. Apologies for the technical issues. This is a brand new platform for us, and we're obviously some glitches. My question, Renata, was, do you have any questions for John? I don't.
Yeah. John, I'm curious about where you're going next with, I know you have intentions of trying to do some research in other parts of California and other ecosystems, other conditions, and I wonder what the status of that is.
Okay, so I actually am engaged with way too many research projects. So I'd have to know which realm are we talking about in terms of composting?
I'm speaking of the rangeland, compost and rangeland. Yeah.
Okay. So what we discovered was very exciting. You know, we now have an insight in scientific understanding about the mechanism of photosynthetically derived soil carbon. It's a big question. What is the best system to do that in? And you know, I know certainly that the native plant community is very concerned about the consequences of putting compost out on rangeland systems. So I honor and respect that. I'm a native plant person myself. So that does make me wonder, what about arable systems? And so to that end, there's vineyards and different high value crops are a big question. Currently, the compost that's produced in California is all sold and it all goes into high value crops. So we can't really interrupt that, and we don't want to. There are challenges around getting compost out on raised rangeland systems. So to that end, yesterday at our meeting at Davis, we were describing 12 locations in California where we can go out, where people have invited us in, and to just put small test plots or pilot plots in existing landscapes. And so there's some public lands, private lands. And so important to know, and this is my memory, so someone could correct the actual number, but I think 61% of California is Mediterranean rangeland, or 61% of the rangelands in California are Mediterranean. The Mediterranean system is the system we're most familiar with. And so for me, I'd want to stay in that system and kind of backfill and understand. Our initial research was conducted at the coastal prairie system, which I manage on my ranch, but also up in the Sierras. And by doing that, we bracketed California's Mediterranean rangeland system. We had a coastal prairie and a Sierra foothill. Different climate, different soil, different grazing management, different grass type. Same compost was used in both. Very similar results, very exciting. So I think it's important for us, for the integrity of what we're doing, to now go in between those two extremes and make sure that the same things happen in all the different Mediterranean systems. And that's a lot of what our work yesterday was to do, was to identify enough Mediterranean systems that we could test this idea there. And then we could look at semi-arid systems and first determine if that's even something that would be appropriate, go out from there. I'm also really curious about urban soils and the city sectors and how lands around and in urban systems, suburbia, things like that, how they could be managed for carbon as well. Because those are highly watered, highly fertilized, highly managed systems. And perhaps, and I don't know the quantities, I know there are 4 million acres of golf courses in America. That seems like a pretty significant land area. So if we changed our golf course management to look at compost rather than fertilizers, that would be something. I'm kind of rambling here. Does that get to your question?
Yeah, that's good. Thank you. Yeah.
Yeah, I think that's actually very exciting to talk about things that outside of agriculture, like a golf course, could be sequestering carbon. You know, these are the kind of innovative ideas that we are desperately in need of. I want to thank you, John, so much for spending time with us today and for doing this really, really valuable work. Thank you so much.
It's a pleasure.
Thanks, John.
So it seems like we've been struggling here with technical difficulties. I don't know if the introduction, I think, was lost for most people. I just want to welcome everyone here to Agricultural Solutions to Climate Change, produced by Bioneers. I'm Artie Mangan. I'm the Bioneers Restorative Food Systems Director. Bioneers highlights visionary activists and breakthrough solutions for restoring people and the planet through our annual conference, which will be held on October 16th to the 18th at the Marin Center. Tickets are available at www.bioneers.org. And we're providing a special discount code for all of you who are attending this webinar. Enter the code Soil Carbon, one word, when registering, and that'll give you a $75 discount off of a 3-day pass. So our next presenter is Renata Brillinger. Renata is the Executive Director of CalCAN, the California Climate and Agricultural Network. which is working to create agricultural resilience in the face of climate change and promote policies that create incentives for agriculture to be a climate change solution. So welcome, Renata. And I just want to say that, you know, CalCAN is very unique in that it may be the only statewide organization in all of the United States that focuses on climate and agriculture. With a severe drought in California that we're experiencing, we're already experiencing the challenges of extreme weather events. So my question, Renata, is, you know, how will climate change impact agriculture in California?
Yeah, well, thanks, Artie, for having us on. And I just have empathy for the technological problems. We've run a few webinars too, and it's always just, it's just still an emerging technology for most of us. So, and thanks to all of you for hanging in there through it. If you have any, I'm still seeing a few little questions or comments about technological difficulties. So just help us out if you would, people listening, if you can't hear or see us.
Yes, yeah, let us know and we'll try to fix it.
Let us know. Yeah, exactly. Thanks. So yeah, Artie, again, thanks to Bioneers and you guys for highlighting this issue. I think it was, I don't know, 5 years ago or something that you first had, at least 5 years ago, you first had Climate Ag on your program, and I think you're forerunners in that as well. CalCAN, as far as I know, is actually the only organization in the country that's exclusively focused on this nexus of climate and agriculture. And we'll get to this, but part of the reason for that is that we have a very important policy context here in California that gives us lots of opportunity. And John talked a little bit about that earlier with the cap and trade thing. We'll come back to that. In terms of impacts, maybe I've got some slides that we could try to get up just to give you folks a break from looking at our beautiful faces, if that's possible. But impacts-wise, obviously, drought is a big issue here right now. We're just getting some really scary data all the time about, you know, the impacts this is having on real human impacts. So in agriculture, obviously drought's a big, and water scarcity are a big problem, but also unique to or not unique exactly, but very important in agriculture are the fact that there are new diseases and new pests showing up, because diseases and pests and insects, and weeds, they adapt more quickly to climate changes or weather changes or weather patterns than most other species, because they reproduce so quickly. So we're seeing farmers are having a harder and harder time staying ahead of these new patterns. Of course, we're getting extreme, unpredictable, erratic weather events. All of this is leading to reduced yields in some crops more than others. And then, as I said, this has got real human impacts. So, you know, we've got farm worker, you know, employment dropping in the valley, especially the Central Valley, and there are impacts on their health from the heat stress. There are food access issues already mentioned at the beginning, as food prices start to be reflecting these yield drops. And then public health wise, there are also, you know, lots of implications. So I just want to underscore the seriousness of the issue. There's a few data points that have come out just really recently in the last couple of months. I feel like the summer was just all bad news. Lots of reports coming out. So there was a report out of UC Davis stating that there are almost 550,000 acres, I'm sorry, that were fallowed in this current year. Much of that in the Central Valley, and that translates to a direct hit to the economy of $1.84 billion. That you know it's got real implications, and of course it has a ripple effect as well through the economy. Employment losses, obviously, farm workers are the first ones to be laid off, especially seasonal farm workers, and then that translates again. It has a multiplier effect. So people who rely on the agricultural industry, you know, service workers, truck drivers, packaging plants, that kind of thing, processing plants, that amounts to an estimated 21,000 jobs lost. This has been a record year for pest problems, I'm told. And I don't have data to support that, but that's the Department of Food and Agriculture is saying that. There's this problem in the San Joaquin Valley. They just less than a month ago, there was a report out that as much as 2 inches a month in some parts of the valley are sinking per month. 2 inches, the land is sinking, and you could just imagine how difficult that is for infrastructure and and farmers. And then of course we've got just tremendous horrible stories about wells drying up and water contamination, both, especially again in the Central Valley. So it's a scary time we're in.
Yeah, I mean, the impacts are almost unpredictable and in some cases kind of unimaginable. At a CalCAN conference a couple of years ago, Al Corchenzi, I think I'm pronouncing that correctly.
Corshane. He says it Corshane. Yeah.
Okay. Frog Hollow Farm in Brentwood was talking about his apricots and chill hours. So chill hours, fruit trees need a certain amount of chill hours every year. And if they don't get it, then the vigor of the tree and the production of the tree drops way off. And he was saying that in his orange-red apricots, without not getting only 70% of what they needed in terms of chill hours because of climate change, the blossoms were not forming. The pistil, the female part of the plant, was not long enough for the pollinators to access, and as a result, fruit was not getting pollinated, and he was having crop failure. So, I mean, these are things that are the impacts are extensive in that regard.
That's right. Yeah, and I don't have any data on that. I don't know if there's much out yet, but it's certainly a big problem for a lot of fruit and nut growers. Exactly. But I think we should move on to the benefits or the solutions. It's too easy, I think, to stay in the dark side of this.
So that's exactly where I wanted to go, Renata, is that, talking about climate-friendly practices and the co-benefits in terms of agriculture, right? So can you talk a little bit about that?
Yeah, that's a really important piece of our work and our perspective, and not just us, but the farmers that we rely on to, help us understand the most promising solutions that they can provide is that co-benefit piece. Of course, we have opportunities to respond to climate change, but we also can solve a number of other problems at once if we take a systemic approach. So again, I just wanted to give some examples of some of the main kinds of practices that we think, and not just we, but scientists are revealing can offer climate solutions in agriculture. So soil building, John talked quite a bit about that, and it's probably one of the more exciting arenas, that more and more people are getting interested in and aware of. Not only does building soil sequester carbon, store carbon, and pull it from the atmosphere down into soil where it's helpful, but it also improves fertility, obviously. I think it's obvious, more organic matter in the soil, more biological life leads to healthier plants and better yields. But it also, really importantly in this time of drought, increases the water holding capacity of that soil. The higher the amount of organic matter, the more water gets held, and it's another drought solution or resilience strategy. Integrating into farms more wildlife habitat has all kinds of benefits, whether it's agroforestry or riparian corridors or hedgerows along roadways and field boundaries. Again, tremendous number of benefits, including putting carbon, into those woody plants, but also habitat for insects that help with those pest problems we just talked about, and improved health of the watersheds generally, corridors for wildlife to travel on. And as the climate changes, wildlife, just like humans, are going to have more and more challenges, adapting. So they'll need our help, with having that connectivity in the landscape. Water and energy conservation. Obviously, the less water we pump, the less energy we'll use, and the fewer greenhouse gas emissions. Also, farmers are really able and well positioned to produce renewable energy on their farms. California leads the country in renewable energy production on farms, but there's a lot more opportunity there. And then lastly, farmland conservation. And this is one that is pretty emergent. There was a study out of Davis, UC Davis, maybe 3 years ago now, 2 or 3 years ago, looking at a case study looking at Yolo County, and those researchers showed that urban land, 1 acre of urban land in Yolo County emits 70 times more greenhouse gas emissions than 1 acre of irrigated farmland. So just by preserving farmland and limiting urban sprawl, we can get tremendous climate benefits. We can keep that development contained, avoid the future production of more transportation-related emissions, and of course, this vision of having green belts and farm belts around urban areas, brings to the imagination of this vision of all this food security and vitality between the urban and the rural edge, educational tourism opportunities, all kinds of, in addition to the wildlife habitat and open space. I think actually this is an area where a lot of beginning farmers could be well supported. We have a crisis in our farming population aging out. So again, lots of co-benefits here. I'm not going to dwell on these 2 farm stories, but they're just 2 of hundreds that we know of in the state. Fetzer Vineyard up in Mendocino, there's a list of, this is out of date, I'm sure they're doing more by now, but this is kinds of things that they've done on their vineyard and winery that sort of illustrates some of what I was just talking about. They've really addressed a number of their elements of their farm and business operation from a climate perspective. And then Julie and Joe Morris are down in San Juan Bautista County, where it's very, very dry, 6 or 8 inches of rain a year. And they actually have been measuring carbon in their soils. They just do they do intensive grazing management. So they're moving their livestock, their cattle around regularly, frequently, in these small paddocks, and they've seen an improvement in their forage quantity and their soil health, and they, over a 5-year period or so, are seeing really exciting increase in soil carbon. And this is during a drought, period where the biological activity is lower. So there's just tremendous potential there. These are just 2 of, like I said, hundreds of folks around the state and around the country that are really trying to understand this better. It's tremendously hopeful.
So Renata, what policies are currently in place in California to promote some of these co-benefits that we're talking about?
Well, yeah, so in California, we've got a very unique policy context. There was a bill passed in 2006 under Arnold Schwarzenegger. Senator Fran Pavley there on the left of that picture was the author. She's still in power. She still has her seat down in Santa Monica. She's got a couple more years left before she's termed out. This bill put in place some goals or targets for greenhouse gas reductions, and it has since been rolled out. There's now something like 70 or 80 different programs that the state has put in place to meet this goal. Everything from weatherizing homes to renewable energy goals to transportation related, fuel content in transportation fuels, and then importantly a cap and trade program. That's the most comprehensive one in the country. There's really only one other region in the country that's got a cap and trade program, and it's not as all encompassing. But this program basically puts a cap on some of the biggest emitters of greenhouse gases. It regulates them, and it tapers that cap down over time. So it requires those polluters to emit fewer and fewer greenhouse gases every year, and they have to pay into a fund called the Greenhouse Gas Reduction Fund, right here. That's just in its 2nd year of existence, and I'm going to talk a little bit more about that. But this AB 32 context that we're in is really, in some ways, why CalCAN formed, because we really saw opportunity for some funding and some policies that would accelerate a transition to a more healthy, environmentally, viable farming system. And at the time, and and until we formed, there really wasn't a representative of agriculture at the state level advocating for truly transformative solutions. So that's what we've been doing ever since. Not just cap and trade, but that's a big part of what we've been doing. And there's some really good indications that there is some change coming in 2015, especially. Governor Brown sort of got religion around soil and farm. At least it became more apparent that he understands the potential here. In his inaugural address, he mentioned the importance of the role of farms and rangelands for storing carbon. He has proposed a new initiative that would be administered by the California Department of Food and Agriculture, and it's got this great language. This is just an excerpt about, again, putting in place incentives to store carbon in farms and ranches. And then the current budget year we're in, that started on July 1st, there's up to $2 billion that's still, well, about actually 1.7 billion that's still on the table, that has yet to be allocated from these cap and trade funds, the greenhouse gas reduction fund that I just mentioned. And we're waiting. There's been a delay in allocating that money, but it's a lot of money, and it's we want to see a portion of it go to agriculture. A lot of it's going to go towards transportation and urban environments, housing and solar and electric cars and that kind of thing, high-speed rail. But we're really fighting hard to make sure that a portion of it goes towards incentivizing farmers to put in place these practices. Do you want me to keep talking about the actual specifics of our proposal? Would that be? Should I just keep rolling?
Yeah, I just wanted to, sort of commend CalCAN. Can you hear me?
Yeah. Mm-hmm.
Hello, can you hear me? Oh, okay. Yeah, I just wanted to commend CalCAN for its efforts in terms of directing some of the cap and fund trade money towards agriculture. It's a huge effort. I know it's not complete, and it's a work in progress, obviously. So yeah, let's talk now, Renata, about where the vision from CalCAN in terms of your blueprint interfaces with the state's Healthy Soil Initiative, and how those things can be synchronized and what has to be done to move things forward.
Great. Okay. Well, our basic premise here is that if there's financial incentives for farmers, that'll encourage at least some of the more innovative, forward-thinking ones to put these kinds of practices in place. So that's our theory of change. If we've got as farmers, very few will do the right thing just because it's the right thing to do. They're business people. They're trying to they're trying to make a living. So by putting in place these incentives, these grant programs or cost sharing programs, we think that'll tip the balance. A lot of folks hopefully will start engaging in this putting in place these tools. So we've been advocating this year for these specific amounts of money. We've been advocating for the general concept for about 4 or 5 years, but this is the first year we've really put a price tag on this. So $25 million we think should be allocated in this current budget year to on-farm practices. This is be a competitive grants program for farmers. They could apply much like the Farm Bill conservation programs, and they could get money for doing any number of these kinds of practices. The details are, would have to be worked out.
And would that include the work that John Wick is doing?
Absolutely, yeah. I think they and the people they work with are in a strong position to benefit from this. We would like to see $40 million be put towards farmland conservation. Last year, the state invested $5 million in permanent easements, permanent protections of farmland around, to prevent development. It was a very small amount of money in a big state that's losing farmland rapidly. So we think there's good, and it was greatly oversubscribed. There were $45 million worth of applications. So $40 million is what we think it should jump up to. We think there should be $40 million allocated to on-farm water conservation. And in fact, actually there just was a couple of days ago. So we've got that one checked off. The other two we're still fighting for. The legislature did not succeed this session in getting coming to agreement about how to spend this $1.7 billion. So agriculture and a lot of other really important solutions have just been left languishing at the moment, unfortunately. Hopefully they'll return to the question in January. They got bogged down with some very difficult policy questions. But let's say that come January, February, we do actually see some money, maybe in this range being allocated. The next question is going to be, well, what the devil's going to be in the details. Just giving the Department of Food and Agriculture $25 million for a grants program is not going to necessarily lead to the most, effective practices. There are a lot of questions that are going to have to be answered. And we tried to anticipate those questions, and we gathered input from about 40 different experts around the state to try to inform what that program would look like. How would it be designed? What experts would be consulted? What quantification tools are we going to employ to evaluate whether we're getting real greenhouse gas reductions? What's the role of co-benefits? How much should that weigh in? What government agencies should be charged with the responsibility to administer this program? How much money should each project get? How do we figure out how to benefit from the knowledge of those forerunners, the folks who get this money and go out and do projects with it? How do we make sure that they're in a position to educate people and do outreach about what they're finding? Because we need that kind of closed, loop. We need that feedback coming back. I mean, this is really, I can't overstate how groundbreaking this is, to use an agricultural pun. In some ways, like it says here on this slide, in some ways this is shovel-ready stuff. In some ways, this another pun. Sorry. This is stuff that organic and sustainable farmers have been doing for a long time. In other ways, that applying that climate lens to these practices is new, and understanding exactly what the benefits are and how to accelerate the transition is kind of new. So, and doing it in a context where we've got all these pressures, these drought pressures, these pest pressures, these accelerating changes that agriculture is being faced with. These are new. It's a new context, and to some extent these are a new way of thinking about old practices. So, I guess my point just is that we're kind of walking, making the road as we walk it here, obviously not just CalCAN, but all of the agencies that are grappling with this, and the researchers, and then the farmers themselves are really going to be, I think, the leaders on this stuff, and we have to figure out a way to get money into the hands of the folks who are most interested and curious and innovative and adaptive, and then learn from their experience. So this blueprint's available online, and here are a couple other resources as well that you might want to kind of check out. The blueprint itself, the Healthy Soils Initiative is just a 2-page outline for now that the Department of Food and Agriculture has put together. They're gathering public input on it. If you're interested in the Farmland Conservation Program and the easements, then you can check out this website and see what the Department of Conservation is doing. And then our general website is there too, if you just want to sign up for our newsletter and stay on top of this really burgeoning field.
Renata, you mentioned research, and again, at a CalCAN conference, I heard Louise Jackson from UC Davis talk about looking at models that said, what the climate may be in 20 years, what crops would be no longer viable in Yolo County, and some of the crops that may be new opportunities. So research is obviously a key component of all this. Any other interesting things happening in the research realm, or how does research fit into the blueprint?
Yeah, that's a great question. The cap and trade money, that money that we've been fighting for, unfortunately, can't be spent on research, on pure research. It's got to be spent on activities that actually reduce greenhouse gas emissions, and that's good. I mean, that money is coming from, the big emitters of greenhouse gases, and the intention by law is that it fund other voluntary reductions. However, it does leave the research dollars out of the funding stream. But there are other places for that. USDA is funding more and more climate-related research. U.S. Department of Agriculture, that is. The Air Resources Board itself, which is the overarching entity that regulates cap and trade and climate policy, funds some research, and they take public comment on what should be funded. I actually think that a really important field of research will be on-farm research, that we need more participatory research with farmers. And so it's possible, as this Healthy Soils program rolls out, and it says in our blueprint that we think there's a really important role for demonstration projects, because then we will get greenhouse gas reductions, and we'll have some researchers, hopefully with some matching funds, who can harvest the data that those farmers are producing, and use that to keep refining our ideas about what the most powerful solutions are.
So what can people do, to support these progressive policy initiatives? Obviously, we desperately need them, and we need them quickly.
Well, I mean, we try to, not to be too self-serving here, but CalCAN tries to be the megaphone for a lot of voices around the state on this stuff, and we're tracking it. That's what we do full time. So signing up for our listserv will get you access. You'll then be, not only will you get monthly reports on where the science and the policy and the practice is, but you'll also get action alerts when it's time to call your elected representative. If you're a farmer, then you're golden for us. If you're interested in this, any farmers' voices speak very loudly on this subject. So we'd like to hear from you personally. There's certainly ways to plug in, and our newsletter would tell you about them if you want to show up. If you want to come to a hearing in the legislature or at an agency, hearing, and those are really important for them to hear from people all around the state. We sometimes also ask people to meet with their representative in their district. There's some key votes that we need on occasion. So. And then if you're interested in more hands-on stuff, I would turn people to their local resource conservation district. A lot of those folks are working with landowners on climate-related projects, and sometimes there's an opportunity to plug in that way.
Thank you. Obviously, very, very critical arena. Agriculture has this very, very significant role to play in climate change, not only in adaptation, but it can be a real solution to it. And I thank you, Renata, for all the work that you're doing at the state level, to keep California in the forefront as a leader in climate-friendly farming practices, and the really interesting work that John is doing on his ranch. We're very, very grateful for that.
Artie, that actually can't be understated. I want to just underscore that California, the cap and trade program here is being looked to around the world. There's nothing almost anywhere else that's as comprehensive and as ambitious, and a lot of states and other countries are actually waiting to see how we do here. And if it goes well, I think we need another couple of years of track record. Other places are going to replicate, what we've done. And unless agriculture is part of it, they're going to get left out of those other places as well. So we're quite privileged, and it's also a big responsibility for us to get this done right here at home. So
yep, and
thanks again. Yeah.
Yep, I just want to repeat that really CalCAN has been one of the major forces in directing cap and trade money towards agriculture and climate-friendly farming practices. So thank you so much, Renata.
Brian. All right, thanks for having us on.
So that completes today's webinar. If you'd like more information about the Restorative Food Systems Program at Bioneers, please visit www.bioneers.org. And be sure to join us for more in-depth conversations at the 2015 National Bioneers Conference on October 16th to the 18th in San Rafael, California. You can find more content on the Bioneers YouTube station or by subscribing to the podcast of our radio series, Bioneers, Revolution from the Heart of Nature. And once again, for those of you who want to join us in Marin at the Bioneers Conference, enter soil carbon, one word, for a $75 discount for the 3 days. Hope to see you there. Thank you for joining us today.